Hello and welcome to Tensile Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. So you find us at the north side of the Atlanta Hartsfield-Jackson International Airport, just overlooking two of its 5 runways here. Now, Atlanta's famous for many things, such as it's the birthplace of Martin Luther King. It's also where the first glass of Coca-Cola was sold anywhere in the world, and it continues. Atlanta continues to this day to be the headquarters of the Coca-Cola Corporation, as well as some other major corporations such as UPS, Delta Airlines, the news channel CNN, and of course Tensile Corporation. And it's also where the factory is housed, that is manufacturing geogrids to be installed all over the Americas. And of course Atlanta is famous for having the busiest airport in the world. Now, COVID has complicated matters a little bit regarding where the figures stand, but certainly for many years, in terms of both passenger numbers and aircraft movements, it's been the busiest in the world for a long time. So, what better place to talk about the geotechnics of airports? Well, first of all, regarding the geology, if you're going to build an airport, you need a big, flat, open space for obvious reasons. You need good drainage as well. You don't want your airport to be flooded. Also, the design of airport pavements is interesting because the loads from aircraft are very high. So the wheel load under a large aircraft is about 10 times the load from a wheel on a road-going truck, and the tire pressures are about double as well. So when do you think an aircraft applies the biggest load to a runway? You'd be forgiven for thinking it's when it comes into land, just as it touches down. There are some dynamic elements to that force, and you might think that was the biggest load, but that's not the case, because as an aircraft goes on its journey, because of the amount of fuel that it burns, when it lands, it can be about 30% lighter than when it takes off. So actually, the biggest loading on a runway is when an aircraft is ready for takeoff. Now, because of those very large loads, aircraft pavements are much thicker than road pavements. But the types of surfaces still can't come in the same basic types of pavement surface. That's flexible and rigid. So a flexible pavement provides a smooth surface for a comfortable ride, but if an aircraft were to stop on an asphalt surface, that very high wheel load will cause creep in the surface, and you'll get little hollows starting to appear, and that's not going to work. So also, the flexible pavement is not so resistant to aviation fuel. So the flexible pavement tends to be used for runways and taxiways where the aircraft keep moving, although here I think they're concrete runways. But the rigid pavement with the concrete is always used for aprons, for parking areas, such as the area that you see in front of us with this aircraft parked on it now. Because you don't get the creep when the aircraft are parked there. It's resistant to aviation fuel, and the bumps from the joints aren't such an issue in the parking areas. But just like with road pavements, you can install geogrids into the granular base and sub-base layers to mechanically stabilize that granular material. That means you can use thinner layers during construction. That will save you money and reduce your carbon footprint, as well as extending the life of these pavements to reduce maintenance needs long term. And actually at Beijing's new Daxing International Airport, all the taxiways and runways had tensile geogrids installed underneath them to reduce costs at construction and to extend the life of those as well. So, from the busiest airport in the world, a quick overview of the geotechnics of airports. So that's all for this episode of Tensile Ground Coffee. Thanks for watching, and see you next time.